Hello everybody, this is Michael. In this video, we will do the LED module simulation. So from previous video, we already have the LED module code. Now it's time for the simulation. So we new one file first. And then we copy the trace information here. And we change the module name is test bench. Okay, we save it. We save it into this folder. This is LED module test bench TB, and we save it. Okay, so for the LED module, LED test bench, the first thing is to give the time scale. And the time scale is 1 nanosecond here. And the next things, we need to define the clock. Define the clock period. Okay. And the clock period is 20 nanosecond, which is 50 megahertz. And so next we need to we need the module name. So it's module name, and the module name is LED module and test bench. Okay, so this is the module name, and we end the module. Okay, so First, we need to create the test target. So the test target is here. We need to test this one, LED module. Okay. So we need to give it test name. Component name is like LED module. And we need to set in the input-output interface here. So this is like this. Okay. So here we set in the clock. We set in the reset. We also just leave it as this type. So like this. But make it more readable, we make it like this. Okay, key on, key off. So this is LED. Okay, and next we need to define all the input and output signal. Okay, for the input signal, we define it is all as register. Okay. So register clock and register reset in, negative reset, and here register key on in, and also key off in. Okay, output LED we define it as wild type LED output. Okay. And then we needed to create the clock for the module. As usual, we initial the clock as high level, and then we use the always to create the clock after half of the clock period. Divided by 2, and then we reverse the clock level. So by this way, we can generate the clock for the test module, for the test target. Okay, so next we need to create the test flow. So how we test it? So we use the initial begin with, okay, And the first things we reset the system. How we reset the system? We make the reset n as 0, 1 bit 0, because it's low level reset. So when we make this value as 0, it will reset the system. Okay, it will reset system. Okay, reset system, and when we reset system, we make all the input value as 1 bit 0. We initiate all the input value as 1 bit 0 and 1 bit 0 initiate. Okay, so after one clock period, okay, one clock period, this is half clock period, we copy it and move this half one. So this is one clock period. So we finish the reset, make the reset signal is high level, and finish reset system. Okay, and then after this we finish the reset, we will input we will give the first input signal as key on signal, because the status machine will switch status according to the key on signal. So after one clock period, we make the key on signal as high level. So means we have some key is pressed. Here we press key. Okay. And after one clock period, we make the key on signal as 0. So we just give one pulse, key signal, key press signal. Okay, key press signal. So this is one pulse of key press signal. Okay. Also, we can say it's 1 clock. Okay. So this means we press some key and we will delay 500 clock period. Delay for 500 clock period. So means the key press time. How long the key? How long has the key being pressed? Okay. So it is this one, the time. Okay. Okay. So this is the key pressing time. Okay, the key pressing time. So after this, and we make the key off signal. We make the key off signal as the 1. So begin to release. Here, begin to release the key. Okay, make the key off signal as 1. And after one clock period, we finish the reset, key reset signal. Okay, make it as 0. Make it as 0. So this is 1 clock of key release signal. Okay. This is 1 clock press. This is 1 clock release. Okay. So we also make the key release signal last for 500 clock period. Okay. Last for 500 clock period. Okay. So this is here. and this is here. Okay, after 500 clock period, we stop the simulation. Okay. So this is a simulation for the key module, for the LED module. Okay. Okay, so let's go to review it again. Time scale, define clock period, and this is module name. This is module name, and this is interface define. This is test target, test components. This is clock, generate clock for the test target, and this is test flow. Here is reset system, and here is initial the input signal, and here finish the reset, and here we give one key press signal, one clock key press signal, and here we make the key press for 500 clock period and begin to release the key, and give one clock of key release signal. Make the release signal last for 500 clock period and then stop it. Okay, so this is the test bench. So next we need to create our model sim project to simulate it. We new one folder. This is model sim. This is for LED module. Okay. Okay, click, and we will save our model sim software project here. So let me open my model sim software. This is my model sim software. Okay, so this is my model sim software, and let me new one project. Close the current project, and the project name is LED module, and the project location. Project location is here. We copy this one. The project location is here. We copy this one and put it here, and click OK. And edit file, browser, and up, and it is here and here, these two files. Click open, click OK, and click close. Okay, so this is these two files, this one and this one, and then we compile it. Okay, with one error, and let's take a look what's the error. So is this line and near here, and let's take a look. Oh, is this one? Is this line 44 and it's here? Okay, so is this one? So it should be this initial. Is this initial? Okay, we save it. Save it. Type wrong typo. Okay, close it, and then we compile it again. Okay, no error, no any error, and simulate. And start simulation. And click here, click here, click here. So it pop up the simulation interface. Okay, so this is the model sim interface. I added the wave signal in the region. Okay, and then change the timer, and we begin to simulate it, and wait it to stop. Okay, stop here. Okay, stop here. Then we go back to the wave, click here and zoom in. Okay, so let's see here. Zoom on. So here you will see we have 1 key ohm signal. And when we get the 1 key ohm signal, we will turn on the LED, make the LED high level, and then we will check the turn off signal. Okay, and we turn off signal here. We get 1 clock turn off signal. We get 1 clock turn off signal. When we get the turn off signal, we output low level on the LED output signal. So turn off the LED, which means between the turn on, between key on and key off, and the LED is always high level. When we press the key, the LED will be turned on, will be light. Okay, so this is the LED module simulation, and this is Michael. See you next time.